Hello students and welcome to another video. In this part of the section, we're going to be looking at another practice problem connecting the derivative and the derivative to the original function. Let's get started. Alright, so let's start with this question. Based on the graph, at what values does the graph of g of x have a horizontal tangent? We need to give a reason and show an algebraic analysis that supports our answer. So what I'm thinking here is that g of x has a horizontal tangent. It looks like it's happening right there. So at x equal to 1, because the graph of g of x changes from increasing to decreasing. So I see it going from increasing to decreasing there. And let's also come up with another calculus reason for that. So the reason we're looking for is when g prime of x equals 0. And so we're saying it's at 1 when x is equal to 1. So let's take g of x real quick and let me rewrite it in a polynomial form. So 2x to the 1/2 minus x plus 2. And let's find that derivative. So that's going to be g prime of x equals x to the negative 1/2 minus 1. And I'm actually going to spend the time to rewrite that. So g prime of x equals 1 over the square root of x minus 1. Okay? And since we want to see when g prime of x equals 0 right there, I'm going to take my function and I'm going to set it equal to 0. So let's continue this work over here. So when is g prime of x equal to 0? So I'm going to say 1 over square root of x minus 1 equals 0. Okay, add 1 to both sides. So 1 over square root of x equals 1. I'm going to multiply by the square root of x. So 1 equals the square root of x. And all I have to do here to get rid of that square root is just square both sides. So I'm going to square both sides just like that. And so I get x on the right side. So x equals, and then 1 squared equals 1. So g prime of x equals 0 when x equals 1, which we just proved right here. So therefore, g prime of x has a horizontal tangent at x equals 1. So everything that we've done here, everything that's happening in this work is meant to prove that we have a horizontal tangent. And the reasoning, the proof that we've shown here using calculus, we need to have that calculus reasoning behind it. We can't just say, oh, it's increasing or it's changing from increasing to decreasing. We want to have that calculus reason, which is using our derivative. So now I want to see, okay, on what intervals is g prime of x less than 0? We want to give a reason for our answer. So I'm going to say, you want to think about when is g prime of x less than 0? What does that mean when we're given the graph of g of x? So g prime of x is less than 0 when g prime of x is negative. What does that mean to you? And it should have a very clear meaning. When g prime is negative, when the derivative is negative, well, that means the graph, when g of x is decreasing. So let's go up and look at our function real quick. Well, since we know we have a horizontal tangent at 1 right there, that graph is going to be decreasing. It looks like it's going to be decreasing for the rest of that time. So from 1 to positive infinity. So I'll just write that right there. So 1 to positive infinity. Now I want to look at when is g prime of x greater than 0? When is it positive? So g prime of x is going to be positive when g of x is increasing. So you want to use that reasoning. And when is our function increasing? So our function is actually not defined for values less than 0. And so the only part where we're increasing is in between 0 and 1. If you go and you look at your paper, it is just going up from 0 to 1 ever so slightly before it starts to decrease for the rest of the time. Now this part is saying for what values of x is the slope of the tangent line equal to 2. So think about this, slope of the tangent line. What does that mean to you? Well, that should have a very straightforward meaning. A slope of the tangent line equals derivative. Slope of the tangent line is derivative. So we want to see when is the derivative equal to 2. Once you say it like that, it just seems very, very obvious. So we want to see, okay, when is g prime of x equal to 2? Well, g prime of x is 1 over the square root of x minus 1 equal to 2. So I'm going to add 1 to both sides. So 1 over square root of x equals 3. Let's keep this going over here. And so I'm going to multiply by the square root of x. So 1 equals 3 times the square root of x. Let's divide by 3 now to isolate that radical term. So 1/3 equals the square root of x. And then I'm going to square both sides. So square here, add some parentheses, and I'll square there. And so the square root of x squared is going to give me x, and then 1/3 squared is going to be, well, 1 squared is 1, and 3 squared is 9. So that's when the value of x, so x equal to 1/9, that's when the slope is equal to 2. So if you were to think about a small tangent line when x is equal to 1/9, well, that slope at that tangent line, the slope for that tangent line would be equal to 2. And now finally we want to find, okay, what is the slope of the tangent line drawn to the graph of g of x when x equals 4? So let's start with this. What is our point of tangency? You're going to get your point of tangency from the graph. So when x equals 4, let's look at that. So what is that value? So that's going to be 4, 2. So that's going to be my point of tangency, 4, 2. And now I want to find what is that slope of the tangent line. Well, we're given g prime. We've already found that. So let's go g prime at 4 is going to be equal to 1 over the square root of 4 minus 1. So that's going to be 1/2 minus 1, which is going to be negative 1/2. All right, and so now that I have my equation, or I just need to write my equation from this information, it's going to be y minus 2 equals negative 1/2 times x minus 4. So I'm going to go to that point, 2, 4, and my slope is going to be negative 1/2. So let's draw that in there now. And it's going to go down 1 over 2, down 1 over 2, and then in the opposite direction. Put in a couple more dots. All right, and then we're just going to connect them with this straight line. And that's going to be our tangent line right there, and that we just need to sketch in. I hope you understand this practice. I would encourage you to come back and try it on your own. These are very good AP calculus questions, so make sure that you are able to do these on your own, as well as in the homework problems that are going to be coming up. There are 3 videos left, 3 more examples that I want you to take a look at, so stay with it. If you do need any help on this particular problem, make sure you reach out to me. You guys know I'm always here to help y'all. So thank you, everybody. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.